Hey tens! Today we're going to learn about systems of linear equations. In this video, we're going to learn about how we solve for two variables using substitution. Some terms to know. A linear equation is an equation that forms a line when graphed. A system of equations is two or more equations that are related to one another by two or more variables. These equations do not have to be linear, which is why we are learning about systems of linear equations. A solution in this case is a coordinate or coordinates that make all equations in the system true. So, an example of a linear equation would be something like this. 2x minus 3y is equal to 5. While this might not be a form that you're familiar with, it's pretty easy to convert this into slope-intercept form, which is where y is equal to something x plus something. So if we wanted to convert this into a slope-intercept form, we would subtract 2x from both sides to get this, and then we would divide by -3, and we would get y is equal to -5/3 plus 2/3 x. Or we can switch these and make it y is equal to 2/3 x minus 5/3. Now, in this form, we can easily see that this equation has a slope of 2/3 and a y-intercept of 0, -5/3, which is why it's called slope-intercept form. But that's not the focus of today's video. What the focus is something like this. Y is equal to 3x minus 1 and 2x minus 3y is equal to 5. Now that second equation is the same as the first one. I've just added another equation with it. So this is an example of a system of equations. So we have two variables, y and x, that we need to solve for, and these two equations are related by x and y. So now that we know what a system of equations is, let's move on to the next slide. So how do we solve a system using substitution? Well, first we isolate one of the variables in one of the equations, if this hasn't been done already. What this means is that we put this into slope-intercept form, but it can be slightly different. After we do this, we substitute what that variable is equal to into the other equation. This will give an equation with one variable, which we can solve. So we solve for that variable, and then we plug that result into one of the equations, one of the original equations, and solve for the first variable. Now this will result in us getting our solution, which we put into coordinates, so x and y. Checking is a good step when you're solving systems of equations. When you check, you can find any mistakes that you might have made while solving it, and you can correct those mistakes. Or you can find extraneous solutions. So, given all this, let's solve some systems of linear equations. let's take the first one. And before I show you how to do these, I encourage you to pause the video and try them out on your own. Alright, so we have 2x minus y is equal to negative 7, and y is equal to 3x plus 8. So you can see that we already have y isolated here, and y is equal to this expression, 3x plus 8. So we can substitute this for y. That would equal 2x minus, since y is equal to this whole expression, we need to put this in parentheses. Alright, now we can distribute this negative. Combine like terms. Add 8 to both sides. And then multiply or divide by -1. It doesn't matter which way you do it, both work. So we have x is equal to -1. Now let's solve for y. I'm going to choose to solve for y in the second equation since y is already isolated here and I wouldn't need to isolate it. So y is equal to 3 times -1 plus 8. If you prefer, you can choose the first equation. Plugging in x into either equation works if you want to solve for y. So we have 3 times -1 is equal to -3, and y is equal to -3 plus 8, so y is equal to 5. Now, let's check. Let's put it in the first equation. Two times -1 is equal to -2, minus 5 is equal to -7, and -7 is equal to -7, so that's good. Now the second equation. 3 times -1 plus 8, we basically did it up here, is equal to -3 plus 8, which is equal to 5, and 5 is equal to 5, so this is also good. So our answer is x is equal to -1 and y is equal to 5, but we need to put it in coordinate form. So our answer is -1, 5. Sorry about that. Okay, let's do the second one. 4x plus 5y is equal to 58, and -3x minus 2y is equal to -33. So I'm going to choose this one because it doesn't have any negatives, and isolate y. So 4x plus 5y is equal to 58. You can already see that this is going to be some ugly work. 5y is equal to 58 minus 4x, since we subtracted 4x from both sides. Then we divide by 5 on both sides, and we get y is equal to 58 over 5 minus 4/5 x. See, it's gonna be ugly. Now, since we've isolated y, we can substitute it for this thing. So we get -3x minus 2 times, in parentheses, 58/5 minus 4/5x. And this is equal to -33. Now we distribute this -2, or yeah. Minus 2 times 58 is equal to 116, so that's 116/5. -2 times -4/5 is equal to +8/5, so that's plus 8/5x. And that's equal to -33. Now, for convenience, we want to change both of these so that they have the same denominator, 5, so we can add or subtract them easier. So, -3x is equal to -15/5x, and -33 is equal to -165/5. So now we can add these together and we can add these together. Or, yeah. So, -15/5x plus 8/5x is equal to -7/5x. And this is equal to -165/5 plus 116/5, since we're adding this to both sides to cancel it out. That is equal to -49/5. Now we multiply both of these by -5/7, since that is the same as dividing by -7/5. And then we can simplify this. 49 becomes 7, 7 becomes 1, negatives cancel out, 5 and 5 both become 1, so this is basically 7 times 1 over 1 times 1, which is equal to 7. So, x is equal to 7. Now, let's solve for y. So again, I'm going to choose this equation since it has no negatives. And I'm going to divide this so that we have enough room. Four times 7 plus 5y is equal to 58. We get 4 times 7 is equal to 28. 28 plus 5y is equal to 58. 58 minus 28 is equal to 30. So 5y is equal to 30. And y is equal to 6. Now we check. Let's plug it in to both the equations. 4 times 7 plus 5 times 6 is equal to 28 plus 30, which is equal to 58. 58 equals 58. so that's good. And negative 3 times 7 minus 2 times 6 is equal to negative 3 times 7 is equal to negative 21 minus 2 times 6 is equal to 12, and that is equal to negative 33, and negative 33 is equal to negative 33, so we're good on that too. So our answer is x is equal to 7, y is equal to 6, or in coordinate form, 7, 6. Thanks for watching. If you liked this video, or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, please put those in the comments below. And remember, the comment section is the equivalent of a class discussion, so if you have any answers to any of the questions, you may answer them. If you have any suggestions as to how I can improve my future videos or what I should do next, please put those in the comments below as well. If I like your suggestion, I'll be sure to put that in the next video and give you a shout out. See you in the next one.